Hi there guys, and welcome back to iTTV for this mathematics lesson. And my name is Joel, your tutor for this lesson. Alright, so we are still at number bases and we have learned, lots of things about the bases, that we have been looking at, base 2, base 8, base 5, so these three bases are the new bases, to us, because we have been used, to using numbers in base 10. So before we begin, with this lesson, let's take a look, at a brief, review of what we have learned in the previous lesson. So we have learned how to convert a number in base 10 to base 2, 8 and 5. And also vice versa. So we can actually do the conversion. So remember the techniques used, repeated division, or the quotient method, or the expanded notation method. Now, we are going to take a look at a specific conversion in this lesson. So we have also learned how to convert a number in base 2 to base 8 and vice versa. Remember, using the special grouping technique. This lesson is divided into two parts. In part 1, you will learn to convert between base 2 to base 5 and vice versa, as well as base 8 to base 5 and vice versa. In part 2, you will learn to add and subtract numbers in base 2. Base conversion involving numbers in base 5. Step 1. Identify the number to be converted. Step 2. Convert the number to base 10. Step 3. Convert the number in base 10 obtained to base 5 by repeated division. Alright, so as long as base conversion involves base 5, for example, you want to change from base 2 to base 5 or from base 8 to base 5, you have to go through these three steps. Alright, so what we're going to do right now is take a look at our first example. Convert the following numbers in base 2 to numbers in base 5. Alright, so don't worry, it is very simple. You just have to remember what we have learned in the previous lessons. A. 101101 in base 2. B. 11001011 in base 2. So remember the task, changing these numbers to base 5. So let's take a look at the first number. So remember, when we want to convert from base 2 to base 5, we have to go through base 10. So it's just like a middle checkpoint. So from base 2 to base 10 and base 10 to base 5. So now let's take a look. First of all, apply the expanded notation method and convert it to base 10. So 101101 in base 2 is equals to 2 to the power 5, because it is actually 1 times 2 to the power 5, right? So it is just 2 to the power 5. Plus 2 to the power of 3, again the same thing happens here. Plus 2 to the power of 2, plus 1. Why 1? Because that 1 is actually 1 multiplied by 2 to the power of 0. So it gives you 1. So we are actually now, using the expanded notation method to convert it to base 10, which will give us 45. So once you have gotten that number, apply the repeated division method and divide repeatedly with 5. So we have learned that as well. So remember, the remainders at the side will be read from bottom to the top. So what will we get is 101101 in base 2 is equal to 140 in base 5. So remember, you have to use this two-step method, or rather 3 steps, but 2 main steps are there. So expanded notation and repeated division. Why don't you guys try the second one? So 11001011 in base 2. So how do you change it to base 10? Remember, using the expanded notation method. 2 to the power of 7, again, because it is actually 1 times 2 to the power of 7, but you can just write it that way because now we just want the sum. Plus 2 to the power of 6, plus 2 to the power of 3, plus 2 to the power of 1, plus 1. So we get 203 in base 10, not over. So we have to divide it now repeatedly with 5. So what will you get are the remainders. And read it from the bottom to the top. So 1100, 1011 in base 2 is equal to 1303 in base 5. Okay, now let's take a look at the next example. Convert the following numbers in base 8 to numbers in base 5. A. 367 in base 8. B. 4251 in base 8. Alright, I'll give you guys some time to try this out. Okay, so remember, as long as base 5 is involved, alright, and in the conversion, okay, involving base 2 or base 8, you have to apply, okay, the 3-step method as we have discussed just now. So now for A, let's go over to the board and I want you guys to just check out your solution. Okay, so let's take a look at the number again, alright? 367 in base 8. So remember, the task is to change it to base 5. Okay, so first step, let's change it to base 10 first, okay, because we have to go through, alright, base 10. Okay, so this method is only used if base 5 is involved, okay, together with base 2 or 8. Okay, so 367 in base 8 is equals to, alright, now let's make it, alright, as expanded notation. 3 multiplied, alright, with 8 to the power of 2 plus 6 multiplied with 8 to the power of 1 plus 7 multiplied with 8 to the power of 0. Okay, so we have to actually sum it up because that will give us, alright, the number in base 10. Alright, so what will we get? Alright, will be 192 plus 48 plus 7. Okay, don't forget, alright, the 8 to the power of 0 is actually 1. So 1 times 7 is 7. So let's sum up, okay, this, and we will get, alright, 247 in base 10. Okay, now let's change it to base 5. Okay, so remember, from base 8 to base 10, from base 10 to base 5. Okay, so 247, and if you want to change it to base 5, we have to divide it repeatedly with 5. Okay, so remember the technique. What number multiplied by 5 gives you nearest to 247? And it will be 49, because 49 multiplied by 5 gives you 245. And the difference with 247 is 2, so the remainder is 2. So go on, divide again. Okay, so now 9, alright, times 5 gives you 45. Okay, and 45 and 49, there is a difference or a remainder of 4. Okay, so go on. Alright, 1 times 5 gives you 5. So 5 and 9, remainder 4. Alright, and then once everything is in place, when the number here is smaller than 5 on the outside, finish it with 0. So 0 times 5 gives you 0. 0 and 1, remainder of 1. Okay, so read it, okay, from bottom to the top. So 367 in base 8 is equals to 1442 in base 5. Okay, so conversion complete. Alright, now for B, the solution would be, I want you guys to check your answer right now. So 4251 in base 8, change it to base 10. Okay, so by using the expanded notation method, and you would get 2217 in base 10. Alright, and the second half, alright, of the process, we will divide 2217 with 5 repeatedly. So 4251 in base 8 is equals to 32332 in base 5. Alright guys, so the good news is now we have managed to cover all the conversions, alright, involving the bases. Okay, so remember the technique, okay, if you want to convert a number from a certain base to another base. Now let's move on to the next part, alright, in this lesson, which is, alright, the addition and subtraction of numbers in base 2. But before that, let's quickly take a look back at how the addition process is carried out in the decimal system. We are familiar with the addition and subtraction of numbers in base 10. for addition and subtraction operations in base 2, several rules have to be followed. Before we get into the rules, let's consider the addition of ordinary decimal numbers. For example, 153 plus 29. Alright, so how do we add it? Very simple. All of you know the process. Okay, so we will get a sum of 182. We begin by adding 3 plus 9 equals 12. Since 12 is greater than 10, the 1 is carried to the tens column and the digit 2 is recorded in the ones column of the sum. Next step is adding 5 plus 2 plus 1, where the digit 1 is from the carry over. Alright, so it equals 8. The digit 8 is then put into the tens column, alright, of the sum. Thus the answer is 182. Alright, now let's look specifically at the addition and subtraction rules in base 2. Addition and subtraction of numbers in base 2 works in the same principle, but several rules have to be understood. Okay, so we have to understand a few rules. Let's take a look at what are the rules involved in addition. Addition rules. Okay, 0 in base 2 plus 0 in base 2 gives you 0 in base 2. Familiar, right? 0 in base 2 plus 1 in base 2 gives you 1 in base 2. 1 in base 2 plus 0 in base 2 gives you 1 in base 2. And this is, alright, very important. 1 in base 2 plus 1 in base 2 gives you 1, 0 in base 2. In decimal form, 1 plus 1 equals 2. However, in binary addition, any digit higher than 1 will be carried to the next column on the left. Okay, so since in base 2 there is only the digits 0 and 1, after 1, alright, will be 1, 0 immediately. Now, subtraction rules. 0 in base 2 minus 0 in base 2 gives you 0 in base 2. 1 in base 2 minus 0 in base 2 equals 1 in base 2. 1 in base 2 minus 1 in base 2 gives you 0 in base 2. And 1, 0 in base 2 minus 1 in base 2 equals 1 in base 2. Okay, now let's take a look, alright, at a few examples involving the addition and subtraction of numbers in base 2. Let's start with this one. Find the sum of the following numbers in base 2. A. 1, 1 in base 2 plus 1, 0 in base 2. B. 1, 0, 1, 1 in base 2 plus 1, 1, 1 in base 2. C. 1, 1, 1, 0, 1, 1 in base 2 plus 1, 1, 1, 0, 0, 0 in base 2. D. 1, 1, 0, 1, 1 in base 2 plus 1, 0, 0, 1 in base 2. Alright, for addition, it's very fun and simple. Now let's take a look at how we're going to find the sum by going over to the board. Alright, now let's take a look at the first one. Alright, so 1, 1 in base 2 added with 1, 0 in base 2. Alright, so how do we add? Remember, okay, similar to addition, alright, of normal numbers in the decimal system. Okay, we have to just arrange it first. Okay, arrange it and align it nicely in the columns, okay, according to the place values. Okay, so how do we add? Pretty simple. Okay, so remember the rules of addition. 1 plus 0 gives me a 1. Okay, so what about this? 1 plus 1. Okay, just now, one of the rules there gives me 1, 0. Okay, so the sum of these two numbers in base 2 is simply 1, 0, 1. Alright, in base 2. Now let's take a look at, alright, slightly larger numbers in base 2. Okay, how do we add this? Pretty simple. First of all, just write down, okay, the numbers, okay, and make sure they are arranged in their, okay, respective columns. Okay, now I want you to do this together with me. Okay, so how do we add? 1 plus 1, and 1 plus 1 is 1, 0. So the 0 is here, and the 1 goes on top right there. Okay, so don't forget, number in base 2. Okay, now 1 plus 1 plus 1. So 1 plus 1 is 1, 0. 1, 0 plus 1 is 1, 1. Okay, so 1, 1, alright, put this one there, and just go on with the addition. 1 plus 1 is 1, 0. So the 0 will be here, the 1 will be here, and then 1, and this one added up will give you 1, 0. So addition is very fun. Now let's take a look at other numbers in base 2. Okay, what about this one? We have 6, alright, digits in each. Okay, so just check it out right there. So it will be 1, 1, 1, 0, 1, 1, added with 1, 1, 1, 0, 0, 0. Okay, I want you guys to do it by yourself right now. Alright, so 1 plus 0, 1. Okay, so all the rules at once. 1 plus 0, 1. 0 plus 0, 0. Okay, so I'm applying all the rules. Okay, now 1 plus 1 is 1, 0. Okay, so 1, 0, the 1 is here, 0 is here. Like normal addition, just remember base 2 only 2 digits, 0 and 1. Okay, 1, 1, 1. Added up gives me 1, 1. Okay, and same thing here, 1 plus 1 will give me 1, 1. So this, guys, is the sum. Okay, and lastly, alright, so what is the sum of both these numbers? 1, 1, 0, 1, 1 in base 2, added with 1, 0, 0, 1. Okay, so don't forget that the arrangement is very important. So 1 plus 1 is 1, 0 again. Okay, so you'll be just hearing, alright, 0 and 1, 0 and 1 in base 2. Just don't get confused with it. Okay, so 1 plus 1 plus 0 gives me 1, 0. 1 plus 0 plus 0, 1. Okay, nothing to bring over. 1 plus 1, 1, 0. 1 plus 1, 1, 0. Okay, so the sum, alright, is easy. Addition, alright, is a very fun process. Alright, so for addition, alright, the rules are there. Okay, now let's take a look at subtraction. Find the difference between the following numbers in base 2. A, 1, 0 in base 2 minus 1 in base 2. B, 1, 0, 0 in base 2 minus 1, 0 in base 2. C, 1, 0, 1, 0 in base 2 minus 1, 1, 0 in base 2. And in D, 1, 0, 0, 1, 1, 0 in base 2 minus 1, 1, 0, 1 in base 2. Okay, now let's do this together. Okay, now let's begin with the first subtraction, which is actually very simple, okay, because this is actually one of the rules that we have looked at just now involving subtraction. Okay, 1, 0, alright, in base 2 minus 1 in base 2, okay, will just give us 1 in base 2. Okay, this is very important to remember because after 1 is straight away 1, 0. Okay, don't forget it. Okay, now let's move on to the next one. Alright, what is 1, 0, 0? Alright, minus 1, 0. Okay, so subtraction. Alright, as usual, 0 minus 0 is 0. Right? Okay, and then after that, straight away we get 1, 0 minus 1. And the rule states that 1, 0 minus 1 is 1. Okay, so we get, alright, the difference between these two numbers will be 1, 0. Okay, now let's take a look at the next one. 1, 0, 1, 0 in base 2 minus 1, 1, 0 in base 2. Remember, all you have to do is to arrange it in the columns right there. Okay, and then, okay, just apply subtraction. Okay, to each column starting from here. 0 minus 0, 0. 1 minus 1, nothing. Alright, 0. Okay, so after that we get, alright, 1, 0 minus 1, which is simply 1. Remember that rule? So the difference will be 1, 0, 0. Alright, and finally, what is the value of 1, 0, 0, 1, 1, 0 in base 2 minus 1, 1, 0, 1 in base 2? Alright, so this is a subtraction of two numbers in base 2. So now let's take a look at how do we get, alright, the result. Okay, so remember 1, 0, 0, 1, 1, 0 in base 2 and arrange, alright, all the digits according to their place values. Now, how do we find, Okay, and how do we subtract two numbers? Okay, so in this case, there is, all right, a little bit going on, all right, and it can be, all right, from the concept of borrowing, because we need to do that. Okay, now let's take a look right here. 0, can we take 0 and minus 1? There is no way we can do it, right? Because 0 is less than 1. Okay, so if you come across this case, remember to borrow from the neighbor. Okay, and the neighbor is 1, right? So every time borrowing happens, 1 0 is borrowed. Just remember that every time you borrow 1 0. And 1 0 minus 1 now can happen. So it will be 1. Okay, so now let's move on to the next column here towards the left. So once, okay, this 1 has already lent, okay, there will be no more. Okay, so we will just be left with 0. And now 0 can minus 0, which is 0. Okay, so now let's move on. 1 minus 1 also gives us 0 without any hassle. Okay, now we come across another situation here. Alright, same like the early part. 0 minus 1. There is no way it can happen. So it has to borrow from the neighbor. So it borrows from this 1 0 right here. Okay, so it borrows, and every time you borrow 1 0. So you're borrowing from 1 0. Okay, so 1 0 minus 1 gives us 1. Okay, and since 1 0 has already lent, okay, there will be nothing left right there. Okay, so the result is 1001 in base 2. So in this lesson, we have learned how to convert numbers involving base 5, alright, with numbers in base 2 and base 8. Okay, and in the second part, we have also learned how to apply addition and subtraction of numbers, perform addition and subtraction of numbers in base 2. So alright guys, that's all we have for you right here in this lesson. Alright, I hope you've managed to get something out of it. I'll see you guys in the next lesson. Alright, so until then, it is goodbye.